Good day. During the next few lessons, I'm going to discuss with you interpretation of graphs from the grade 11 syllabus. The examples that I'm going to discuss with you are all from this Mind Action Series grade 11 mathematics textbook. We are going to focus on two very important aspects within graph interpretation. The first one that we will discuss are when we have inequalities as part of graph interpretation. And the second one is where we have nature of roots as part of graph interpretation. Let's look at the first example. In this problem, they say that the following sketch shows the graph of fx equal to x squared minus 6x minus 7. That is the parabola that you will see here on the drawing, as well as a straight line graph, gx equal to ax plus b. As you can see, the equation is not given to us, and that is the straight line, and we're definitely going to find this equation later. They also told us that t is the turning point, so t represents the turning point of the parabola. TPN and QRS are perpendicular to the x-axis. Now you will notice that TPN is over here, that is that vertical line, and the second one, QRS, that vertical line, and they are both perpendicular to the x-axis or parallel to the y-axis. Within the first question, they ask us to find the length of AB. Now, when you look at the drawing, you will notice that A represents the x-intercept of the parabola, as well as B. B also represents the x-intercept. So for us to be able to find the length of AB, we need to find the x-intercepts. So how do we find an x-intercept? We say for x-intercepts, what do? We let y equal to 0. So we will take the equation of the parabola, that x squared minus 6x minus 7, and we will put it equal to 0 so that we can find those x-intercepts. This is an easy trinomial to factorize because of the fact that 7 is a prime number, and the factors of 7 will be 7 and 1. To get the answer of minus 6, the 7 must be negative and the 1 positive. As you can now see that minus 7 plus 1 is negative 6. So now we're going to say that x minus 7 is equal to 0, or x plus 1 is equal to 0. So that means x is equal to 7, or x is equal to minus 1. So we can now put this 7, you will agree at the point B, that will be 7. And the minus 1 I'm going to put here with A. So as you can see now that this A, the intercept with the x-axis is at minus 1, and B is at 7. Now the moment they ask us for a length, we can't get a length with a negative value. So this minus 1 shows you the position of this point. But that length between A and the origin will be 1 unit. And from the origin to B, that will be 7 units. So AB will then be a total of 8, because it's this part, the 1 unit, plus the 7. So we can now say that AB will be equal to 8 units. So it's a fairly easy question. You just need to realize that you need to find the x-intercepts of this parabola. The second question, they ask us to find the coordinates of C. Now, C, you will notice, that is the y-intercept of the parabola, as well as the y-intercept of the straight line. But we don't have the equation of the straight line, as you remember. Up here, they didn't give us, but they gave us the the equation of the parabola, which is this one. So if I want that y-intercept of the parabola, I'm going to substitute x with 0. So let's do that. Y-intercept, we substitute x with 0. So we get now that y is equal to x squared minus 6x minus 7. That is the equation of the parabola. We're going to substitute x with 0. So we're going to say this is 0 squared minus 6 times 0 minus 7. And I hope you agree that y will be equal to minus 7. So this point here at C, we can now say without a doubt that this point will be at minus 7. So let's put the minus 7 there, and then it's easier for us to see. Now the question was to find the coordinates. So that means to find the coordinates of C, we need the x and the y coordinate. Now, as you can see, that we substituted x with 0, so that is our x coordinate, and we calculate y, which is equal to minus 7. So this coordinate of C will be 0, minus 7. So far, so good. Not too difficult, so let's move to the next question. In this question number 3, they ask us to find the values of a and b. Now, if I can just take you back to the previous screen, that a and b is from that straight line equation. So basically what they want you to find is the equation of the straight line graph. Now, please take note, we have this point B, which is on the straight line graph, and that point B is the point 7, 0. And we also have point C, which we just calculated as 0, minus 7. So let's now go and find the values of a and b. So first of all, the b within the straight line equation, and that equation was y equal to ax plus b, you will notice that this b represents the y-intercept, which is the same as the y-intercept of the parabola. So we can now say that b will be equal to negative 7. So we still need to find the a, this one, and that a represents, as you look at this equation, the gradient of the straight line. Now, we have two coordinates, b and c, on the straight line. The coordinates of b is 7 and 0, and the coordinates of c is 0, minus 7. Now, because we've got these two coordinates, you will then be able to find the gradient of that line, and that the gradient will give us the value of a. We've got b already because that is the y-intercept, which we know from the parabola is minus 7, so the y-intercept of the straight line will also be minus 7. So let's find this gradient, and I'm just going to call it a. It's not really the symbol for gradient, but that is what we are going to calculate. Is equal to the gradient, so we just say this is gradient, and we use the little formula that all of you know. y2 minus y1 over x2 minus x1. So let's just substitute the values. So we say it's minus 7 minus 0, if I subtract the two y values, and then 0 minus 7. And you can now see that we will get an answer of 1. Because it's that negative 7. So as you can see here, the negative 7 minus 0 is minus 7, and 0 minus 7 is minus 7. So negative 7 divided by a negative 7 is positive 1. So that means we've now answered the question where they ask us to find the values of A and B. So we can summarize this now just by saying that A is equal to 1 and B is equal to negative 7. If we need the equation later, we can also write down this equation of the straight line now. But let's move on to question number 4. In this question, they ask us to find the coordinates of T. Now, when you go to the drawing, you will see T represents the turning point. So we must find the turning point of the parabola. Now, to do that, we're going to just write down the equation of this parabola. So it's x squared minus 6x minus 7. And we're now going to find the axis of symmetry first. And that is we use the little formula x equal to minus b over 2a. So when I substitute the negative, and the b is negative 6 over 2 times a, which is 1. And you can see I will get a positive 6 divided by 2, and my answer will be 3. So this 3 represents the x value of the turning point. And you will notice I've put it there right at the x value of the turning point. We now need to find this y value as well. To get the y value, we will substitute this x equal to 3 back into the equation of the parabola. So we will say that to find y, we will say it is 3 squared. And when you substitute, always substitute in brackets. And that's 3 minus 7. And now we can work that out, which is quite easy. 3 squared. 3 squared is 9. Minus 6 times 3 is 18. So we get 9 minus 18, which is negative 9, minus 7, which will give us negative 16 for the y. So that means we can now write down the coordinates of t, and the coordinates of t will be 3 minus 16. And always put it on your drawing as well, because that will help you in questions to come. So with that, we are finished with question number 4. And now we're going to go on to question number 5. The length of PT. We need to find this length. So let's just first of all see where PT is. And you will notice PT is right here. We need that length. And that length, you will see, is a vertical length, so that we will get from the y values. So we need this y value, and we need this y value. But you will agree with me that this y value we calculated already as negative 16. So we still need to find that y value. And that will help us to find the length of PT then. So let's do that. So the x value at point P is equal to 3. And I hope you agree. That is point P. That's the x value of point P is 3, the same as t. So not to get confused, I just wrote it as the x of P, just refer to it belongs to point P, is equal to 3. So how will we find the y? I'm now going to use the straight line equation. Remember, we solved already a and b. So I have x minus 7 as my equation of the straight line. And we're going to substitute y equal to, and we substitute that x with 3 minus 7, and this answer then will be negative 4. So that is our answer for y for point P. So this value will be minus 4. So now for us to write down the length of PT from here to there, we must look at this y value and we look at this y value. But you can see both of them are negative, but a distance is always positive. So that means we can take this one, that length will be 4 units. The total length will be 16 units. So you agree that PT then will be 16 minus 12. So we can now write down the length of PT. So we can say that PT is equal to, and I'm just going to point out again, we're going to take this x value at minus 4 and this x value at 16. Please remember that length is 4 units, the total length is 16 units. So to find PT, we can just say 16 minus 4, which will be equal to 12 units. And with that, we are done with question 5. Let's look at number 6. They want us to find the length of OR if QS is equal to 18. Now, when you look at the drawing, you will see that QS is here, right there. That is a line, a vertical line, between the parabola and the straight line. And they gave us that length as 18. And they ask us to find that length from the origin to R, to find OR. So how will we do that? First of all, whenever we want a length of QS, what we need to do is we need to take the equation of the parabola, or the y of the parabola, which is the equation. We subtract the equation of the straight line. So it's parabola subtract straight line. So we can now say that QS is equal to the equation of the parabola, which is x squared minus 6x minus 7. And we're going to subtract the straight line, which is x minus 7. And we can now simplify this, but we also know that QS is 18. So we can substitute QS with 18, and then just simplify the right-hand side, which is 6x minus 7 minus x plus 7. And you will agree we will get x squared minus 6x minus x is minus 7x. This minus 7 plus 7 subtract to 0. The 18, if we take it across, will become minus 18 equal to 0. So there we have a trinomial now that represent the length of this line QS. So we're going to factorize it now so that we can find the x value of the line which is given to us here. So I say x and x. The factors of 18, that will give us 7, will be 9 and 2. My answer must be negative 7, so the 9 gets the negative, the 2 will get the positive. So that means now that x is equal to 9, or x is equal to negative 2. All right. So the important thing here is that this x of negative 2, you will hopefully agree with me, will be this x value. that x value will be negative 2. So that is the x value of r. That will be at negative 2. This x equal to 9, we're not going to use this one, and we just say this one is not applicable. So we're only going to use this x equal to negative 2. So we can put that negative 2 here right at r, that is negative 2. And now we can just write down the answer. Remember the question was to find the length of OR. Now to get OR now, we will just go what is the distance from 0 to that negative 2, that x-intercept minus 2 from 0. And you will agree that distance is 2 because the length is always positive. So we can now say that OR is equal to 2 units. And we are finished with number 6. Question 7 is a fairly easy one. They want us to find the range of f. The range of f is what they want us to find. Now f, as you can see, is the parabola. And if they want the range, it means they want the y values that is valid for this parabola. And as you can see, these y values are from this minimum point at minus 16 right up to infinity. So there are 2 ways to write it down. So first of all, to find this range of f, we can say that y is greater as well as equal to negative 16. So it's negative 16 and higher, where this y is an element of all real numbers. Or we can also write this in interval notation, where we say that y is an element of minus 16 up to infinity. Infinity is always open. Minus 16 is included, and that means it will get, like you see, it will get the square bracket because it's included. Because that minus 16 is included in the range, and it goes up right up to positive infinity, as we indicated here. You don't need to write both of them down. I'm just showing you, you can, whatever you prefer, you can either look at the set builder notation or the interval notation when you answer this question. In the B part, we now get to the inequalities that I was referring to you earlier. Now we've got all our information on our drawing. We know the turning point, we know the axis of symmetry, the x-intercepts, the y-intercept, we know the equation of the parabola as well as the straight line, and we now need to find where f, the parabola, is greater and equal to gx, which is the straight line. Now, whenever they want us to find this relationship, if it's greater or less, doesn't matter, fx, gx, but whenever they ask us an inequality between 2 functions, the question means that we need to find where the one function is, for this particular one, if they say greater, that is where it is above the gx. Now, to do that, we need to look at our drawing. For us to be able to find it, we need to look at where it will change. And this order will change where one function is greater than the other, right at the point of intersection. So right here where the 2 graphs intersect, you see the straight line as well as the parabola intersect at C. And that is where the order will change. So before we get to that point, less than 0, you will see that the parabola is above the straight line. After the point of intersection, the straight line is above the parabola. And there's another point of intersection, and then the parabola is above the straight line. Now, for you to be able to see it, I'm going to draw two vertical lines, and I'm going to draw them, and it's very important to notice where I draw them. I'm going to draw them right at the points of intersection. On the graph, I'm going to draw a vertical line here, and I'm going to draw a vertical line at that point B. That is also a point of intersection. Right, you can now see my two vertical lines. This one covers the y-axis as well, but for our discussion now, it doesn't matter. So as you can see now, we've got three intervals. We've got the interval here, that is all the x values less than 0. Then the in between 0 and 7, and then from 7 and greater. And now we need to write this answer. So when we look at this side of this red line, you will agree that the parabola is above the straight line. So that means the parabola is greater than the straight line. And that is exactly what they wanted us, what they asked us to find. They want us to find for which x values the parabola will be above gx, the straight line. So let's write down this first answer. And the first answer will be x less than 0. The important thing is you always need to think if you must include equal as well. And equal means where the two graphs intersect. And then we look at our question, and you can see they also included the equal. So they wanted to know where it is greater, fx greater than gx, but also equal to gx. So that means we will include that one. And now we're going to look at the next interval. So you will see these lines divide this drawing into three intervals. This one, so you check this one, which graph is greater than which one. Now we look at this part. This part, the straight line is above the parabola. It doesn't matter that they're below the x-axis because it's only between the two graphs that we need to know the relationship. So the straight line is greater, so that means gx is greater than fx. And as you can see, it's not what we want. So this is not part of our solutions. So now we look at the third interval. And this interval, within this interval, from 7 onwards, you will see f is above g. Quite clear to see that f is greater than g. So we can write this down. Take note, we say or, because it can be, x can be less equal to 0, or x can be greater equal to 7. And for the same reason as for x less equal to 0, we say now x greater equal to 7. Because at 7, the two graphs are equal as well, and equal is included. And that is the solution. So let's look at another inequality. So let's now look at the second inequality in this question. And within this inequality, they ask us to find x where fx times gx is less than 0. So we must do a multiplication, and we must get an answer less than 0, which means negative. So what they ask us is that we must multiply the two functions, and we must get a negative answer. So when will we get this negative? We will get the negative if the one is positive and this one is negative, or we can also get a negative if this one is negative and that one positive. So what it means in terms of the functions is that if the parabola is positive, the straight line must be negative. Or if the straight line is positive, the parabola must be negative. So they must have opposite signs. So the important thing to understand here is where do we find where a function changed from positive to negative or negative to positive? And that happens right at the x-intercept. So if you look at this x-intercept, do we agree this side of -1, the parabola is positive? But now if I go here, there it is now negative. So this part is positive, this part is negative because it's below the x-axis. When a function is above the x-axis, it's always positive. When it's below, it is negative. You can see that changes right here at -1. The function positive, and it changed to negative right at that point. So I'm going to draw vertical lines again for this one, but please take note, I'm not going to draw it at the point of intersection of the two graphs like we did in the previous one, because that was where we answered the relationship between the two functions. We now want to find where the product of the two graphs is negative. So that means I'm going to draw the one line right here at this x-intercept, and I'm going to draw the other one at this x-intercept. So now it is about x-intercepts. In the previous one, it was about the points of intersection. Now it's about x-intercepts. So let's just draw those lines. So you can see now my two vertical lines, this one at this x-intercept and the second one at this x-intercept at x equal to 7. So we're now going to look at the three intervals again, but now we're going to look at this interval from -1 to this side, which graph is positive, which one is negative, or are both of them positive or both of them negative. So you will see to the left of -1, the parabola is positive. And you can now also see that the straight line will be negative. And as we said before, if for a certain x value, the one graph is positive and the other one negative, then it means that the product will be negative. And I'm just going to write it down here at the bottom. Now I'm also going to look at the second part, the second interval. It's now this interval between -1 and 7. As you can see now, here the straight line is negative and the parabola is also negative. You can see because both of them are below the x-axis. Remember, if the graph is below the x-axis, the graph is negative. Above the x-axis, it is positive. So you will agree that this negative times this negative will give us a positive. And then I'm going to look at the third interval. And this is the interval from 7 up to infinity. And here you will notice that f is positive, that's the parabola. And the straight line is also positive, which means the product will be positive. Now, our question was, where is the product negative? So we said when the signs are different. And as you can see, this is the only one where the product is negative, because that interval, the product is positive, and this interval, the product is positive, this interval, the product is negative. So we want this answer, those x values. So we can write it down that x must be less than -1. I want you to take note that we're not going to include the equal sign here because the equal was not part of the question. So we only wanted to know where the product is less than 0. That means negative. We don't want the product to be equal to 0. That was not part of this question. So with that, we are finished with this inequality. For the last two questions, they ask us about to find coordinates of the turning point, but they give us a transformation here, but within fx notation. Now, for us to be able to answer this question, it is really important that you must understand this notation. This notation means that it is the f of x minus 2. That is the y. So what we must do is we must take the f of x function, which is the parabola, and we must shift that parabola. And the question is, how do we shift it? And the easy way to do it, you take this part that is inside the bracket, that x minus 2, you let it equal to 0, and then you say x is equal to 2. So it means we need to shift the parabola, or for this matter, the turning point. We're going to move it 2 units to the right. Now, we know the turning point of this parabola because we found it already. And that turning point was the point t, 3 minus 16. Now, we're going to find the image of this one, that is the symbol we use for a transformation. And we are going to move this turning point, this one, 2 units to the right. That's where we will take this point, that point, 2 units to the right. So you will agree that minus 16 will not change because that is a y value. The x value will change. So if we change the 3 and we move it, that point x equal to 3, 2 units to the right, you will agree it will move to 5. So this turning point will become 5 minus 16. Take note, the y doesn't change, only the x. And to know how to move it, just look at that transformation and you know it will move 2 units to the right. So 3 will become 5. Right, let's look at the last question of this example, and that is y equal to the f of minus x. So they want the coordinates of the turning point again, and like we said before, we know this turning point is at 3 minus 16, and now they want us to apply this transformation on it. Now, as you can see, the x now is a negative x. Now, whenever we change x to a negative x, what does it mean? That means it is a reflection. We're going to reflect this function f in the y-axis to find this and I'm just going to call it t image again. So let's just have a look at our drawing. This is our turning point, 3 minus 16. They want us to reflect this point in the y-axis. This is the y-axis. We reflect it, so it will be here. Now, as you can see, the y values will be the same. It is the x value at 3. If we reflect it, it will become minus 3. Because remember, that distance is 3. That distance must also be 3. So our answer, minus 3 minus 16 for the image of that t. So that is after we applied that transformation. Thank you.